Hello, and welcome to Learn System View in 5 minutes. This is Tutorial 23 on getting started with mixed signal analysis with RF link in System View. So in System View, till now we have been performing mainly two type of analysis. One, in the beginning of this tutorial series where we talked about a QPSK modulator implementation and the validation of that modulator. And in the last few tutorial videos, we have been focusing on doing the RF transmitter and performing all kind of different analysis with this RF transmitter. Now for mixed signal, we need to combine these two different domains of our system inside a single test bench. And that capability is provided using a RF link component in System View. Let's see how to use that. So first of all, I will go ahead to Tools option and I will enable to see multiple workspaces at the same time. Because remember, in our case, we have one workspace, which is RF system tutorial, and that's capturing our RF transmitter. And we do have another QPSK modulator workspace. That's where we were working on this QPSK modulator implementation. Now, as both of them are different workspaces, I need to do copy paste and bring over either the modulator design into the RF system workspace or to bring RF system design into QPSK modulator workspace. So in my case, I will go ahead and copy the RF transmitter design by simply right clicking, select copy, and then under the designs folder of this workspace, I will go ahead and paste it. Now notice, because design one was already existing there and I was copying over the design with the same name, SystemVue was smart enough to avoid that conflict and rename this design to design 2. Now we can go ahead and close the RF system workspace because we have all the required designs here. And I will go ahead and delete some of the earlier data and data sets we had in our QPSK design. Now, another thing I would like to do is rename these designs so that I know exactly what I'm looking at. So I will go ahead and call it, RFTX. And I would go ahead and rename design one to be called as QPSK underscore sys, representing QPSK system. So once these two basic things are in place, I can go ahead and open QPSK system design, which basically looks something like this. If you recall, in one of the earlier tutorial videos, we worked extensively on this design. Now, to place the RF transmitter onto the mixed signal design, so it's always the RF block, which will get placed as a sub-circuit in the overall scheme of things, because data flow simulator is the actual mixed signal simulator for us to use. So we can simply drag and drop the RF designs over to this data flow schematic. And whenever you do that, remember, System View will read the signature of the block which you're trying to place. And as soon as it senses it's a cross domain kind of design, it converts the RF block into an RF link equivalent. And we can now go ahead and pass on our QPSK IF data, which is 70 megahertz, into this design. Now, if you remember, we were also doing 70 megahertz input design, and we had all the configurations set accordingly. And the output frequency, which will come out here, will be 2.4 gigahertz, as you must have seen in the last few tutorial videos. Now, in order to see the output spectrum, we could connect the same spectrum analyzer sink at the output, and we can go ahead and give it a new name, say RF underscore output or RF output, as we may want to call it. So once we give it as RF output, we can now distinguish which signal we are looking at when we perform simulation. Now we have the complete mixed signal representation ready for us to simulate. Now in order to simulate that design, one more change we need to do in the system controller or the data flow controller. Remember, the original design we were working with was known as design 1. Now we rename that design and we will need to pick QPSK system, which is basically this schematic here. Also notice SystemVue is smart enough not to pick the RF TX design because it knows that design cannot be simulated using the data flow simulator. So we'll retain that. So once we click OK, the simulation gets performed. As you can see, the RF link block gets characterized and the characteristic gets transferred into data flow. And we have a new data set here. Now, if we double click on the data set, we can notice the modulator output, which is basically nothing but our transmitter input, which is IF. And then we have a transmitter output, which is RF. So let's go ahead and plot the power spectrum in a new graph, and you can notice the IF frequency at 70 megahertz. Similarly, I can go ahead and plot RF output power and look at what happens at 2.4 gigahertz. And you can notice the spectrum looks quite distorted due to the RF nonlinearities got added. And we can go ahead and try tiling all the windows so that we can see all of this together. So we can click on this icon again, close the unnecessary. And now you can put this window side by side and notice the distortion caused by your RF transmitter. Well, that's enough for this video to get you started on mixed signal simulation, in SystemVue. In the next tutorial video, we will look at a little more advanced topics on how to do in-depth data, processing for a mixed signal system using the VSA link we have in SystemVue